So in the last classes what we have done is basically we have talked how we can convert word into embeddings. It's either embeddings or they are also known as vectors, so word vectors. So basically now you have the words, they are converted into vectors or numerical values, right? So our task was, when you are starting an NLP task, right, there are a few things that you need to make sure. First is pre-processing. So you need to pre-process the data, right? That is important. Next we talked about was basically tokenization. Now after tokenization, what did we talk about? We talked about converting into vectors, or vectorization you can call it. The final step of this is basically, now what has happened is basically your words have been converted into numerical values. Now these values are fit to be trained on models. Okay, so now you can train on models, right? So now our next task will be basically training it on models. So now what we will be going to do is, we are going to talk about the different models that it can be trained on. Okay, so that is what is going to be the task or the whole point of this whole topic. Okay, we are going to talk about the different ways how once you have the vectors, these vectors can be now passed into models and can be trained using them to give you more values, more embeddings. Okay, so we will understand the whole task of it and we'll understand it one by one. So the structure that we are going to talk about right now is RNN. So RNN basically stands for recurrent neural networks. So let us understand this, and first let us talk about what this is, why we need this and everything else. And also we'll talk about why we cannot use basic CNNs or basic multi-layered perceptron for tasks which involve words. Okay, we'll talk about each and everything. So first let us talk about one of the problems, that is using MLP and CNN. Why can we not train what is basically a sentence, right? So let us suppose we have a sentence: Sheila lives in France. She is a painter. Now here if you will see this she, when you look at it, when you read it, you will realize this she refers to Sheila here, right? So it refers to this person here, but that only you can understand is basically because you have the memory of the previous sentence, right? You have the knowledge of the previous sentence. Now this is one of the problems that happens in CNN and MLP, multi-layered perceptron. If you think about the architecture, what it does is basically it understands what is inside the image, or not just the image, what exactly it constitutes of, the features of it and everything. Okay, but it does not understand, or it does not keep into memory what was there in the previous image, or it does not form a sequence of the image. So it does not understand how the first image is connected to the second image. So this sequence, basically this understanding of sequence cannot be done using CNNs or multi-layered perceptron. Think about the architecture one more time, right? So in the architecture what is happening, you are training the whole model so that it can extract features from image. So extracting features, yes, that can be done. You can extract features from image and everything. But the point is, see, it is not just you have to extract features. You also have to understand the sequence. Sometimes, let's say in a video, you have a video, so the next frame is totally dependent on what happened on the previous frame. So you have to understand the whole context of this, right? You wouldn't have understand who this she refers to had it not been the name here in the previous sentence, right? So this understanding of whole sequence is why we require a new type of architecture, and this architecture is basically your recurrent neural networks. So talk about RNNs now. Okay, so let me tell you one thing. So RNN, what it does is, the main part or main important part of this is basically it keeps the memory of previous data or previous input. So that is one thing that is very important. So it keeps into account what was there, what was trained previously. So it helps. This RNNs are basically used for sequence task. So if you talk about sequence tasks, you can think about sentences or understanding a paragraph, understanding what is written, all the words and everything. That is a sequence, because see, what is basically a sentence? A sentence is basically a sequence of words, right? So RNNs are basically used for our sequence tasks. So first you can have that is basically understanding your NLP task. So RNN can be used for NLP task, or sequence tasks are basically NLP tasks. The other is time series. So time series is also sequence based. So it has to understand what was happening previously at that time or a particular day or something, so that it can basically analyze what is going to happen in the future. Alright, so that is basically all your sequence tasks. Okay, and this can be done using RNNs. So we are going to talk about RNNs. These are the most basic structures. Then we will go on and talk about the different other sequence based techniques and tasks and networks. Alright, so let us first start with RNN. So this is basically your structure of an RNN. Now this looks a bit weird, but let us talk about this. So first you have the input. It passes through an RNN cell. RNN cell gives out two outputs. One is the output from the particular cell itself. The other is basically, this contains the memory of the previous cell. The actual structure of RNN, if you talk about it, the actual structure, if you talk about it, is basically like this. Okay, so you have the first cell, you have the second cell, you have the third cell. All these cells are connected one by one, okay, in a sequence. And the two things that it takes into account is basically the input at that particular cell, or it is also known as input at that particular time. Since this is sequence based, right? So sequence is basically more of time related things. So input at that time, it makes sure of that, and it also makes sure of what was the context or memory of the previous states or previous cells. So it takes into account two things, right? So these are the two things that take into account. If you look into any RNN structure, right, this is the basic architecture. See, here also you have the same thing. This will go in here, you'll have this, then you'll have what is a tan H, and then this here, and then this will be connected. In the same way, here also you'll have the same thing. Hence, this can totally be represented in this format. So this basically is what we call as the rolled version of RNN. So if you unroll this, so this is the structure. If you unroll this, what you will get is basically something like this, one after the other, different cells. We'll talk about what this input at the particular time means and what everything else is. Okay, we are going to understand each and everything, but this is basically the architecture of a simple RNN structure. So two things you have to remember. See, whenever you get anything like this, don't get freaked out. This is basically what is the rolled version of RNN. Okay, once you unroll it, so it becomes something like this. Okay, you have the inputs, you have what is the memory state or the hidden state from the previous cell, which keeps, so this basically keeps into account or context what was happening earlier. Okay, so let's say suppose you had this sentence, right? We were talking about this sentence. This Sheila lives in France, she is a painter. Okay, so this is the sentence. So what we can do from here is, what we can understand, let's suppose this here, this represents the word she. So here you have the input she. Okay, or no, let's say here you have to output she. Okay, so you have to output the word she here. So to output this, it has to understand the previous sentence where it says Sheila lives in France, right? To understand this, what it does is, it basically uses what is known as your memory state or your cell state. We'll talk about all, or hidden state. Okay, so these are the different terms that are used. We'll talk about all of this in details, but what this basically means is, it takes into account what happened previously, so that it can understand whether this should be she or he or it or anything in that format. Okay, so this is basically the whole of RNNs. Now there are a lot of things that can get very confusing when you talk about RNNs. Okay, so I have to first discuss about all of those as well. So when talking about RNN, right, if you look into TensorFlow 1, it calls RNN layer as RNN cell. Okay, so that is one thing that can get very confusing. RNN layer basically means this whole thing here, all the RNN cells that are connected one by one so that they can predict one particular output in this format. This is basically known as your RNN layer. Okay, so different RNNs which are attached to each other, okay, in the same level, this is a RNN layer. So that is an RNN. Okay, the other thing is basically your input size that is going into it and the output size. We are going to talk about this in details. Okay, so now let us look into this and let us try and understand what is happening here. Okay, so you have the input, you have input. So this is, see, RNN unrolled versions, like I was saying about, all these are unrolled versions. So you have different time steps also. So let us talk about the time steps first. So when we say time steps, right, let us understand this with an example. So let us go back to the same example. Sheila lives in France. She is a painter. So time step means at a particular moment, at a particular cell, what is the basic input, that is the time step of it. Okay, so here if you think about it, this has 1, 2, 3, 4, 5, 6, 7, 8. 8 time steps. Right, so it will have what, 8 different RNN cells attached to one another. Okay, so this will go on, this will be till 8. Okay, so till the 8th RNN cell it will be like this. So you have that, so that is basically your time step. So time step is basically at a particular time what is happening. So like I said, you require for RNN, you require 2 things. So one thing is basically, the first thing is the input at the time step, and the second is your hidden state or previous state. Okay, so these are the 2 things that are required, hidden state or previous state, and the input at the particular time step. So these are the 2 inputs that an RNN takes. Okay, now how will this input actually go in? So when taking in the input, right, so your input, if you talk about TensorFlow 1, it is in this format: batch size, this is followed by time steps, the number of time steps that will be required, that, and this number of time steps is basically the number of RNN cells that will be used in a particular layer. Okay, and then finally feature size. So feature size is more like how we were doing basically in neural network, basic neural network or stuff like that. Okay, so let's suppose you have an input, okay, and you have the number of features. Then if you change the number of neurons, the number of features are going to change. So that is what basically here the the feature size basically means. Okay, so that is basically your input size. Your output, so outputs can be in varying formats. Okay, we are going to talk about that. But if we talk about an output from one particular RNN cell, okay, so that output is basically equal to 2 things. So the first thing will be basically equal to your batch size, and so the size will be basically batch size, and this will be followed by your output feature size. So this is basically your input and output, and it is very important. I am saying this, I haven't even discussed about the architecture yet, I am pointing this out. This is because, see, this gets very confusing when you start using TensorFlow 1 and you don't realize what is happening. So it is important to understand these 2. Now let us understand what is happening in the whole architecture. Okay, so let us start with the first RNN cell. Okay, so here what happens is you have the hidden state going in. Hidden state means the state that was there in the previous cell. Since this is your first cell, there is no hidden state, so all your values are 0. Okay, so that is one input that is going in, and here you have the first input. So if we are using the sentence, same sentence, Sheila lives in France, let's suppose this is a sentence. So here your input will be Sheila, actually word embeddings for Sheila. Word embeddings for Sheila. Okay, so here what will be the input shape like? Let's suppose my word embedding is of 100 dimension. So here what will be the shape like? So I will have 1, 100, right, because of the first word Sheila. Okay, if the whole thing would be going in Sheila lives in France, so in that case Sheila lives in France, so this will be 4 comma 100. And here you also have the batch size, but since we are using only one particular sentence, so this will become 1. So 1 4 comma 100, this is will be your input. Okay, so you have now two inputs. This is, we are talking about the first RNN cell, by the way. We are going to talk about each and every RNN cell. So your initial hidden state is 0, so everything is 0 here. So the first thing that will happen if you think about this is, you have your hidden state from here which is going in. So here this is your hidden state is here. This gets multiplied by hidden weights. Okay, so you have your state here. So let us see the same conventions that have been used here. Okay, so your initial input is HB. Okay, so this is your hidden state. This will be multiplied by HW. Oh sorry, your hidden state is S. I'm sorry. So S will be multiplied with HW and it will be added with HB. So the hidden state is multiplied with weights and bias is added to it. This is your very first step. The second, what will be happening is the same thing will be happening for your input. So your input is I at time t, obviously I at time t. Okay, this is also, let us take it as 0 because this is S or input state at time 0 and this is I or input at time 0. So I0, this will be multiplied with weights IW and this will be added with what is known as your bias. Okay, once you have this and this, the next thing what will be happening is they too will be passed through a tanh function. So you have now two things. You have the input going in, here you have the hidden state going in, you have the weights going in from here, you have the input going in from here, hidden state from here. They both get multiplied with weights, added with bias and they pass through what is known as a tanh. Okay, so that happened. So it has been passed through a tanh, right? So after it has been passed, what it gives out is one value. So let us talk about this one by one again. Okay, let us understand this, what is happening. So first what is happening is, you have your input I0, this is at time step 0. This is at time step 0, you have input I0, this will be multiplied with weights and what will be added, a bias will be added, your first step. Next what will happen is, basically the same thing will happen to the hidden state. Since this is your initial hidden state, okay, so this will become S0, it will be multiplied with what, hidden state W and it will be added with hidden bias. Okay, so this has been done. Once you have these two values, what will happen is they will pass through a tanh function, right? Now it has been passed through a tanh function. Next thing what will happen is, once you have the tanh function, this will be basically acting as your H1 or this will basically become your hidden state 1, right? So you had this, and what will happen once you have this output, let's say this is H1, you get the output as H1. So H1 will be multiplied with what? It will be multiplied with some weights again, HW, and bias will be added, right? And once this has been done, this will basically be your output Y at time step 1. So you are getting two outputs. If you see here, if you see, you are getting two outputs. One output is basically your hidden state, that will be acting as the hidden state for the next cell, and one output is basically your Y output, the output that you are getting from each cell. Okay, so these are the two outputs. So now let us talk about what will happen in the second cell. So the whole concept will be the same thing if you think about it. So here what will happen, let me just change the color. So here what will happen, this is your, now this was my hidden state 0, this passed, and here you have hidden state 1. So this is your hidden state 1, this is xt, but here it will become x1 because this is my first word. Okay, so or this is my word at time step 1, time step 0 is done, so now time step 1. So here it will both go here, so I1. So yeah, the input is I1, so this is I1. So we had the thing for Sheila. Next what we are going to do is, we are going to go for the next one. So Sheila is a painter, right? So that, or the first sentence was Sheila lives in France. So now lives will pass here. Okay, and lives is basically what? This will be in the form of what? Your word embeddings. So word embedding for lives will pass here as the input. This will get multiplied with what? So I1 will now get multiplied with IW. Now mind you, the weights for here is going to be different from the weights from here. For each RNN cell, the weights are different. So now multiplied with IW, what will happen? IB will be added to it. Okay, so this happened with your input, you get the value here. Here what will happen? Here the same thing will happen. Now this is basically your hidden state 1, which is S1. So S1, what will this get multiplied with? It will get multiplied with HW, that are the hidden weights, and then what will be added? Hidden bias will be added. Okay, so these two happened. Now these two will pass through a tanh function. So this is an activation function. So what will happen when you are using an activation function? An activation function will then give you some non-linearity, right? If you remember, we talked about it. So now you have some non-linearity. It has been passed to an activation function. What output will you be getting? S2. That is the hidden state 2. This value you are going to get here. And your output will be passed as your output for lives will be passed here. And how will it be passed? So it will be multiplied with your, so S2 will now be multiplied with some weights and a bias will be added to it. So I hope you are getting this. This is not that hard. It is a basic sequence to sequence model. Here what is happening is basically you are inputting two values. One is a hidden state and the other is input state. So they in itself pass through some linearity. Once it has passed through some linearity, what will it pass through? It will pass through some non-linearity. These are your activation functions. And once that has been done, you have the activation functions pass through. It will again pass through some linearity. And this activation function here, it will give you your output as your hidden state for the next cell. Okay. And this linearity, now this will give you the final output. And what output will that mean? What will happen? We are going to talk about it one by one. Okay. So this is basically all of your RNN architecture. So RNN itself is of many types. Okay, we are going to talk about it. You will understand one by one what I am talking about. Okay, so this is a basic 1-to-1 architecture. So what does that mean? So that means you have one input and you have one output. So you do not have many cells. So this is a 1-to-1 architecture. So this is basically a basic neural network. If you think about it, since there are no more other cells, there is no concept of memory storage. So in that case, what will happen? If there is no concept of memory storage, it is a basic neural network because there is no sequence involved. It cannot understand sequence or anything. So this is basically your normal neural network. Okay, here is the thing I just forgot to mention. This might be easier to understand. So this is passing one by one. Okay, so you have Sheila, it passed here, you got some output. So now what is passed? Lives is passed. Okay, and then this will go on till France, lives in France, and suppose she is passed. Now since all these states have been going on for a long time, right? So that means it has some attention, some remembrance of what happened previously, right? It remembers some of the things. So it, since it has been passed earlier and it contains all those values, then so it contains the value. Okay, so we talked about Sheila is a girl. So when the she will pass, it will actually take that into account. This is how basic sequence to sequence works. Okay, so you have earlier what was happening, see, if you think about it, earlier you had a set of neurons, all of the values passed at the same time and then it went through some other neuron. Here it is not going to happen like that. It is a set of neurons but they will pass one by one, hence understanding the sequence of it. So this is your basic neural network architecture. Okay, so there is no change here. Next what we are going to talk about, see here, if you think about it, this is a many-to-many architecture. Sorry, this is a one-to-many architecture. This type can be used in what is known as music generation. If you think about it, you gave one tune to it, okay, and the few further tunes, everything, it is being generated on its own. Okay, so here what is happening is, if you think about it, here there is no input. Okay, so there is no x1, x2, x3 inputs like that. There is just one input, that is the first tone of it or first tune of the music. The rest, the input is basically whatever it is generating. Okay, this type of architecture is known as one-to-many architecture. So here you have one input and many outputs, hence one-to-many architecture. Next here if you think about it, what is this? This is basically a many to one architecture. You have many inputs and one output. So this can be used where? This can be used in something known as sentiment analysis. If you think about it, how does that work? Let's suppose I said this is a good deal, right? So this is a positive sentence, but you cannot understand by just reading this is or a, right? You have to read the whole sentence as together as one, okay? So each and every, if you think about it, each and every word will be passed one by one, so that finally what happens, it has now a sequence, or it has an understanding of the sequence of the sentence. It understands now the whole sentence as it is, and then it will be able to say, okay, this is a positive sentence. So this can be used in sentiment analysis, okay? So I know you might have learned about sentiment analysis in machine learning. It is also used in deep learning, and most of the times it is solved using RNN problems or RNN structures. Then here you have a many to many architecture. Now this is used in NER. NER is named entity recognition. You might remember this when we were talking about Spacy, TextBlob and other libraries, right? So in that time we mentioned about this. So here what it does is, you have one input, the input will pass through the structure, and then what will happen is, it will say what type of the word it is, okay? So if this is a let's say a name, a person, or if this is a place or something like that, so it will tell you about that using this named entity thing. And also if you think about it, some words or some words actually, they have a different meaning if they are used in a sentence, or they can mean something else, okay? So that is why you need to have a sequence. So you have a sequence, but at the same time it will be able to understand your named entity recognition, whatever names it is. So it belongs to a location, a person, or so on. And then here you have, this is also a many to many architecture, but this is for an encoder decoder model, okay? We'll talk about this. This one is something that we are going to discuss in details, but what happens here is basically, see, you have the input. So this is basically used in Google Translate and everything. Think about it, okay? So you have an input, and your input is, let's say, in English. You want to convert it into Hindi. In that case, you are going to use what? This many to many architecture of RNNs, okay? So you will have the inputs, all the inputs will go here in English, okay? It will understand each and every word, so it is able to understand the whole context of the sentence. Then it will pass again through the leftover architectures or leftover RNNs, and they will be responsible for generating the whole thing in Hindi. Because see, you cannot generate one word at a time in Hindi, okay? You can do that, but the whole sentence will not make any sense, okay? Because the ordering of words or the ordering of particular things in a sentence is different for English, and the rules for ordering is different for Hindi, okay? So you cannot for each word translate and just give that out. No, we also need to understand the sequence of it. Hence you will have the first few RNNs where they will just take the input in English, and the left RNNs that will take or give you the outputs in Hindi, okay? And this is done for most translation languages, okay? So that is it. I hope you understand the video, and don't get very scared or frightened by this. This is very easy, very interesting in fact. So the whole point of this is basically, we were talking about different RNN structures. So the very first thing that we talked about is basically how this whole construction works, okay? So we talked about why do we need sequence models, and then we talked about how this works. How does this work? So you have the input, and along with the input, it also takes into consideration the cell state of the previous cells, okay? So it knows what happens in the previous cells, it keeps a track of it, and that can be used for our advantage to understand words, understand sentences, paragraphs, and so on, okay? So you pass it here, and what happens? It gives out two values. So first value is basically the output that will be generated. The second is the hidden state. So this hidden state is basically an accumulation of all the previous RNN cells, okay? And how does it do that? You have two different formulas to it, okay? So the first formula is tan h of, so you have the input I0 IW plus IH, and this is followed by S0 multiplied with HW plus HB, right? So this is the tan H of whole thing. This will give you what? Your hidden state 1. Sorry, S1. This is for S0, so it will give S1. And then next thing what will happen is basically, let me just change this so that it is more general. So in that case it will happen tan H of IT minus 1 IW plus IH comma ST minus 1 HW plus B. So this is to find the hidden state S at time period T. We have to understand what was happening in the time period before. Okay, so you get that value, then you will, what you will be getting, you will also be getting YT minus 1. This will be basically equal to what? ST into weight plus bias, right? So this is basically the whole point. You get the values here, okay, and these keeps on passing one by one. So you have that. Then we talked about different architecture. So you have one-to-one architecture. This is a basic neural network, nothing new happens here, so we can just skip that because it does not take into account the whole value of sequence. Then we talked about one-to-many architecture, where you have one input but many outputs. This is used in music generation. Then what did we talk about? We talked about many-to-one architecture. This is used in sentiment analysis, where it understands the whole sequence of the sentence and then it gives you an output that whether this is a, what sentiment does this sentence classify as. Next we talked about many-to-many architecture. This is basically used when you are doing name entity recognition, so you can understand the sequence of the sentence but at the same time you are able to classify each and every word. This here is also used for NLTK libraries and text blob libraries. Then here the final thing that we talked about is basically many-to-many architecture, but this is an encoder-decoder system. Here what you have inputs in the first half you have all the inputs so that it understands the sequence, and then in the next part you have to generate the sequence in some different format, okay. So that is one, and this is basically used for language translation and everything, okay. So I hope you understand the video. Take it slow, understand one at a time, and if you have any other problems, do ask your mentors and keep learning.